All right. So let's talk a little domain. Let's talk a little range. So we have a question here. How do you know what form to write domain in? Great. Let's talk about it. So I'll tell you this. The truth is, it doesn't matter what way, how you write domain and range. It doesn't matter if you write it as a paragraph explaining what domain and range happens to apply to the function you're looking at, or you write it in proper set notation, or you write it in interval notation. It doesn't matter really, especially at the high school level, in terms of communicating an idea. Whatever makes you most comfortable, I'm comfortable working with you, um, using that form. For someone who's taken a lot of college classes, I think it's important to be multilingual when you're dealing with domain and range, meaning that different professors will write it different ways. Even like next year, when let's say you're taking calculus here at Battle and you're with Dr. Gassler, I know he writes a lot of set notation, but I know he does it because like he feels like it makes the most sense for students. And so I don't know. To me, like you have to be able to read it all different ways, produce it all different ways. And honestly, in certain contexts, it makes more sense. Or one form makes more sense than the other. Let me try to give you some examples, and then we'll kind of work from there. So the first thing to know, and this is just that mark correct or that colored pencil activity we did in class. So it's important to note that, uh, excuse me, it's important to note here that whatever form you use, you do want to write that form correctly. And so let's talk really maybe briefly about the different forms, and then we'll kind of work from there. So let me get a blank piece of paper here. Okay. And so to me, there's really three ways you can attack domain and range. But let's first establish this. Um, if I'm talking the word domain, all I'm really talking about are all usable x's. And when I'm talking range, I'm talking about all used y's. And so what I mean by that is if you think about a function, any function, I'm going to draw a graph here crudely. And let's say I'm dealing with a cubic, so let's do something like this. When I'm talking domain and range, I'm simply talking about like if you think about the end behavior and you take the biggest value of x and the smallest value of x, what are those? What x values are in between those? Are they all the values or just some of them? This is what I mean by all usable x's. So if you look at the end behavior of this function, this continues unfettered up and to the right, and if you go to the left, it continues unfettered bottom and to the left. And in between, you have a continuous unbroken graph, meaning that you're going to use all the x's. Like if you go to the right far enough, it's not going to stop, and you'll end up at positive infinity. If you go right to the left far enough, it again, it's not going to stop, and so you're going to reach negative infinity. So like for this in one particular, all the usable x's are literally all the x's, every single value. The range, again, you got to think about end behavior. If I go all the way to the right, what's the biggest y value I'm going to achieve? If I go to the left, what's the smallest y value I'm going to achieve in this case? Can I use all the y values in between? And so, like, the idea of end behavior is very, very important to the idea of domain and range. So when you're using end behavior to describe it, or to help you kind of decide it, that's what you should have in your mind. Like, what x values can I use? What y values are used as a result? So let's just maybe write a couple examples here, and maybe that will suffice to answer the question about what form to write it in. So if you think about like just words, like you can just describe it the way I just described it, and you're welcome to write that out and say like a paragraph. It's not typical, especially as you reach at higher levels of math, because all those words will simply kind of get in the way. One thing you should know about mathematicians is we try to be very precise when we write, and we don't want to write more than we actually need. So writing is one way. The other way we talked about in class, which I'm going to again put forth, that I think personally the one that I think is going to be most useful in the long run for you, is what we call set notation. So set notation derives its name from the fact that we're going to write things into as sets of numbers. Now, when I say sets of numbers, The notation here is this. If you had Mrs. Fike years and years and years ago, you know these as Jay Leno's, but they're just what I call squiggly brackets. In other words, just brackets. This is just a standard notation for sets. And so what goes in here is just a set of things, elements, if you will. And you just make them as a list, or you write them in a way that makes sense. And so I'm using blanks here to convey the fact you put stuff in between the set notation. And so like a typical example for domain and range using set notation is this. First, you have to define the variable, and that tells the reader what variable you're trying to identify in the set. Next, you put a vertical line indicating you're now, after you identify the variable, you're now going to tell me how the variable is defined. And then the back end is actually defining the variable. I'm using numbers. Now, what goes in the blue can be a lot of different things. I mean, it could be, it can be like intervals. You can say as like inequalities, like greater than one number but less than another. You can identify the numbers it can't be, and so sometimes it's typical to say, well, it can be every number except for these numbers, or it can just be a list. Like you can just make a list of all the numbers. So let me give you some examples of what I mean. So like for example, let's say we're defining domain and range, and we say, well, we're defining domain, so we're going to define it using x, and we're going to define x such that um, x belongs to, let's say, every number bigger than 4. And so we can write that. So x is every number that's bigger than 4. Or let's say bigger than or equal to 4. And so if we just simply write it like that, that will tell the reader that we're looking for all numbers bigger than 4. Now we can be more precise in this. And again, the level of precision depends on the actual problem. But let's say we wanted to do a little better job and say, well, we want x for every x belonging to the real numbers such that x is bigger than 4. Now it looks like I added a whole bunch of stuff. I just didn't. I want to make sure I'm including all numbers that are real and not leaving it up to the reader to kind of interpret it. So that's one way you can represent set notation. Another example that might make sense is, let's say again we're defining the x values, and we're defining the x values, say that x is in between two numbers. So typically you can write something like this. So we can say like x is less than or equal to 10, but is smaller than or equal to 1. So like that's the way you can kind of combine like inequality notation together with set notation to convey what numbers are okay. Now, just like before, if we want to get super fancy, we can also throw in like the idea that belongs to like the real numbers. And so for every x that belongs to the real numbers, I want x between 1 and 10. Now we haven't really seen, and you probably haven't experienced the need for distinguishing real numbers from something else. But as we continue our study and we talk about complex numbers, well, that was going to make a whole lot more sense. Okay, so I'm just getting you ready for it. I want you guys to see the notation. Alternatively, like another way you can write notation is what we call interval notation. And interval notation takes advantage of a very particular and common form, which is going to look like actually coordinate pairs. In fact, interval notation makes the most sense when you're looking at a graph, I think. And so here's the ins and outs of that. So the first thing to note is that I use two types of brackets, either a curved bracket or a square bracket. Curved bracket indicates exclusivity, and square bracket is inclusivity. In other words, it tells you if you can or can't use a number that's touching it. And so let's say I was talking again about domain and range, and let's say my domain is anything bigger than 4, so 4 to infinity. And so what that example might look like is this. If I could and if I can use 4, I would draw a square bracket. I can start at 4 and end up at infinity, and then close it off with a curved bracket. Curved brackets always touch infinity because it's a number you can't technically reach. So it's a number that so you always use curved bracket to indicate it. So if you're looking at this like in words, this says I start at 4, and I'm going to write inclusive here, meaning that I can use it. I start at 4, then go to infinity. So if you look, it actually means the same exact thing as this first thing I wrote. It's just a different way to write it. And so like these two things, uh, this set notation and this interval notation actually mean the same thing. So let's say I want to write the second one. I'm also using set notation. So if I look at my range here, I'm sorry, the numbers I'm using for x, I'm using 1 to 10, and I can use 1 and I can use 10. And so if I write it in interval notation, I'll start with a square bracket. I start at 1, okay, and I end up at 10. And again, I use a square bracket here as well because I can use 10. So one of the reasons I'm not a particular personal fan of this notation, the interval notation, is because if you look at it, that looks a whole lot like points. Now you want to be able to read it, and so if you see it on a test like the ACT, you understand what it means. I just want to make sure that you know that these two do mean the same thing. I personally think this, although it kind of looks scarier, is actually more useful because you're able to quickly modify and tell me what number sets belong. And also, let's say in terms of just like upper level math classes, like you're going to see this kind of interval notation, or I'm sorry, set notation a lot. So, I want you to understand both. If you want to use words to explain it, that's fine too. That's completely up to you. Okay, so that's a really quick kind of word or two about what it means to have, or I'm sorry, different ways you can write domain and range. Set notation's one. It's personally one that I like a lot. Interval notation's another. It's one that actually makes a lot of sense, especially when looking at a graph. So my encouragement is that you come fluent in both. But that's all I got for you guys. So if that answered your question, hopefully it answered your question. If not, tell me what more I can explain to you, and I'll be more than happy to explain that. Before school, after school, and Ath Lab, don't forget about those if you need to talk to me one on one in person. Otherwise, that's it. That's all I got for you guys. Thank you.